Right triangle application problems. So we're first going to just review the two methodologies we've learned before on how to solve missing sides and angles of a right triangle. And those were using Pythagorean theorem and Sohcahtoa. So depending on what you're missing, you'll pick one of those methods to use. Sometimes you can pick one or the other. So I will have us hit pause after I set up the problem, have you guys just make sure you remember how to solve for the missing sides and angles of a right triangle, and then move on to the application problems. So in the first example, you're given angle A is 32 degrees, and little a, which refers to the side across from angle A. So all the lowercase values refer to the side lengths, and then all the capital letters, the angle measures. So for now, if you can hit pause and then see if you can solve the entire triangle for all the missing sides and angles. So at this point, hopefully you've gotten a chance to try it out. Angle B should have been 58 degrees. It's complementary to angle A. Little b should be 9.6 rounded to the 10th place. And little c is 11.32. One example of a trig ratio that you could have set up to solve for little b would have been tangent. If you were standing at 32, would have been opposite over adjacent. So that's an example of an equation that you could use. For c, we could have used sine of 32 is equal to 6 over c. Now the application problems usually have two phrases, angle of elevation and angle of depression, depending on where the observer is standing. So if you are standing on ground level and looking up, your line of sight is what I'm going to highlight. To the top of that tree is forming an angle with your horizontal line of sight, which is the one of the legs of that right triangle. And the angle of elevation is measured, I will call that theta, down below there. Versus if a person is standing at the top of a cliff, and from that top, your horizontal, and I really should be drawing it to where the horizontal is coming from the line of sight of that person, and the angle that's measured from that horizontal with the line of sight, if that person's looking down at, say, a boat, that the line of sight, the angle measured from the line of sight with the horizontal is called our angle depression. And you can think of that as if you're from looking up from below, you're elevated, or your line of sight is elevated, you're feeling happy, that's an angle of elevation, versus you're depressed and you're looking down. So then the angle of depression is when you're on you're above a cliff, or you're on top of a building looking down at something below. So let's go ahead and do example number 1. You have a roofer props a ladder against the wall. So always draw a picture first. So you have the ladder, it's propped against the wall, forming a right triangle with the wall and the ground. So the top of the ladder reaches a 30-foot roof. So from the top of the roof to the ground level is 30, so that means that this leg is 30. That roof needs repair. If the angle of elevation from the bottom of the ladder to the roof is 55, down here it's 55, how far is the ladder from the base of the wall? So the question that they're asking you is the distance of the base of the ladder, which, let me highlight, from the base of the ladder to the base of the wall would be the other leg of the triangle. So what we'll do is we'll call that value that we don't know x. And we're going to use one of the trig functions above from Sohcahtoa to solve for the missing leg length. So in this case, we have the opposite being 30 from 55, and then the adjacent. So that means we use tangent. We're standing at 55 degrees. That's our angle of elevation. Opposite would be 30, and adjacent would be x. To solve for this, I'm going to multiply both sides by x to get rid of the fractions. So x times tangent of 55 is equal to 30. X is equal to 30 divided by tangent of 55, which when you enter that into the calculator to the nearest foot, that would be 21 feet. One thing to note about angle elevation and depression problems is that the angle of, and I'll have you write that up here, the angle of elevation is congruent or equal to, the measure of it is equal to the angle of depression. And that is because, hopefully, let's see if anyone remembers from last year. Hopefully you remember that it forms a letter Z, so they form alternate interior angles. And so therefore they must be congruent to each other. So the horizontal line compared to the ground, horizontal line is parallel to the ground level. So those angles are alternate interior angles, therefore they must be congruent.